Hello and welcome. We're starting at the workbench today because what I'm going to be doing is a little bit of a rewiring project on the Miata. I wanted to, for quite some time, put in some kind of retro looking switches for the power windows and replacing the rocker switches that were there. I had done a console delete in the center and I relocated them, and I'll show you that in a minute, but I want to replace the rockers with something a little cooler. And now you can go out and buy a kit that basically is just plug and play, and you can do that. But nobody sells one like this with these little flapper things. They're Lucas style. These are not Lucas components. I'm not that crazy, but they're Lucas style. So, kind of like what you see on British sports cars, the Jaguars and so on like that. Back in the 60s and 70s and so on. And so what we have to do for this wiring is the Miata and mini cars use the same type of wiring process, in which it has a DC motor that controls the window going up and down, and it works by reversing the polarity. So if the positive is on one side, it goes up. If the positive is on the other side and the ground's flipped, then it goes down. And so the way we do that is what's called a double pole, double throw switch, and that's what this is. So this is for 12 volt DC. It's 20 amp, which should be sufficient. I think each motor is 10 amp or 15 amp maybe. The fuse is 30 amp, but I think the 20 amp, that's for both running at the same time. So any given switch is only going to have, maybe 15 at most amps going through it, probably not even that. So I think this should be fine. And the stock connector has 6 leads, and so 2 of the leads are for one motor, the positive and negative, and as I said, it flips based on what you want to, what direction it should go. And then the other 2 are for the other motor, and then you have one that's positive always when the ignition key is set to on or run, and then the other one is negative. So then what happens is with this type of switch is a return to position type of switch. So it will click. Let's see if I can do this while holding the camera. It will click and then return to the center. So center is neutral, and then up and down will connect the power or the ground to these different external leads, which I'll describe in a second. So the way this works is looking at the back, and I've got a test probe connected here to my voltmeter so you can hear continuity. We'll do some testing. I'll show you what I mean. You've got 2 kind of that are in the middle, and that's going to be, you're going to connect one to your positive and one to your ground. Constant 12 volts, and your ground connection is the other one. Then whichever one, then you're going to connect the 2 leads to the motor. We have one switch for one motor and another switch for another motor, but 2 leads to 2 of these connectors. Now that leaves 2 other connectors, and you may ask, well, what do you do with those? Well, those need to be jumpered across from kind of a crisscross pattern, and I'll show you why. So here we've got one lead connected up to this, and if I tap this, then obviously I've got continuity right here. In the middle position, it's neutral, so I can hit any of these and nothing will happen. There's no continuity. Now if I connect it here and push, if I can get it, then that's connecting this to this. So if I had power to this, then when I push down, it's going to put power to this one. So what that means is the side of my motor that makes it go down on positive needs to be connected to this one. Now the same is true on up. If I connect it over here and push up, if I can do that. Sorry about the bad camera angle. Can't quite get the leverage. There. Push up, it's the same thing. So the other side is just the same, except it needs to go for the ground. So what's going to happen is you're going to jumper, you're going to have your lead connecting to this side, and then it's going to jumper across to this side from here. So the wire coming in from the motor will hit here, and then it will jumper to that one. And then the wire coming in from the other motor will hit here and jumper across to this one. So there's basically a cross connect jumper. And what that does is it allows the switch to reverse the polarity of the two leads going to the motor. Whereas these middle ones are simple. You just have one wire going in, and one side is positive and the other side is negative. Doesn't matter which one. You just need to arrange them so that up means up and down means down. Even that doesn't even matter, because you can just, on installation, if it's the wrong way, flip it. Very simple. So basically you can wire this up any way you want, almost just with the jumpers across like that, and you'll be all set. Now the next part is when we're constructing this, what we're going to do is we're going to use some of these spade connectors, and they're just a standard size. All three of these are the same size as far as the spade part is concerned and connecting to the actual spade on the switch. But what's different is the gauge size of the interior. So you're going to choose the one that's going to fit with your wiring the best. The smallest one is probably okay, since most of the wiring in the Miata is like a 16 gauge or less. And so basically what we have is actually this one is like an 18 to 22 gauge type of wire. This one will take 16 to 14, and this one, and usually the colors are standardized. So when you pick these up at the store, you can read them, but they'll be a standard size. And so this one is a bigger one for 12 to 10 gauge, and you can see that it's got a much bigger area. So depending on how big the wire is in the harness, I haven't even looked at it yet, we may choose this one or this one to put two wires into. So that's how we're going to make the jumper. We're going to put the regular wire to the motor into it, and then we're going to get some AWG wire, just a little small piece, about an inch long or so, and we're going to jumper it to another one that's going to go across these connectors, these spades, and that's how we're going to build it. So it's easily taken apart. We don't have to solder anything. We're just going to crimp it, and that's gonna get us set up. And before we install, we can test everything out, make sure that's good, and so on. And these switches did not cost much. I think they were about $8 for two of them. And of course these are like a couple bucks for a huge pile of them. And then I also got some guards, which I may or may not have to replace. They're not quite the right size. They're a little bit short. If you look at it, how they line up, they're just a little bit short. So I don't know if I can find, these were a little bit hard to find, but again, these were not expensive either. They were about $7 or $8. So anyway, we will be putting these into just a flat piece of sheet metal that's going to go into the front tombstone where the radio used to be. All right, so back in the car, you can see that I've moved the stock switches from the center console, because I did a center console delete, and I just moved them and stuck them in this plate that I made. Deleted the crappy stereo that was in there, and this is really easy to do, especially if you don't mind flipping this around. So right now, if you push up, the windows go down. If you push down, the windows go up. So if you don't mind that little weird thing for the interface, user interface, then it's very easy to do. And the reason why it's flipped like that has to do with the way the wires route in the back and just the spacing. I wanted this on the bottom. I didn't want it on the top, because eventually I was going to add gauges here, but actually we're going to be replacing this with the new switches. which don't have that problem and can slot in with just a small hole drilled. So the first part is when you're taking apart your console to change out the switches, you have to take off your center console, which is basically just a couple of screws at the bottom, and there are a couple screws normally like under the cup holder, one in the back, and then it'll just slide right off of your gas cap and release levers. And then you'll be able to get at all of this. And normally there are two screws that go up into it from behind here, so you have to take out the eyeball vents and then release those screws. In my case, I don't have it, so they're just kind of loose. It's held in by the bottom screws because I have this going through a custom little spacer here. All right, and once you got that screws released, then you can pull this back. Don't pull it back too far because there's a clip, a socket that connects to your hazard and your headlight thing, which looks like this. I've already popped it out. It has a small release tab right here. You push on that, and it's going to pop right out. But there's not a lot of slack here, so don't pull on this too hard. It's going to be held in. So once you get all that out, this is normally where the screws go that I mentioned beneath the eyeball vents. So once you pop your eyeball vents out, what you can do, most people use a string. They put a string around here and then pull straight back, and they're held in place by these little clips. So you can see how that works. You can pop it out with a screwdriver potentially, kind of prying at it, but you can mar the plastic. So the string method is a little bit safer. So the back of your switch looks like this, and what we're going to be doing is connecting. These two are the wires that go to the DC motor for your window on one side, and these two are on the other side. Then they share a ground, and the red wire in the middle is going to a common positive 12 volts, switch 12 volts. So that's how we're going to be hooking up our new double pull, double throw rocker switches. And we can cut this, which is what I'm going to do. You could potentially replace the harness if you could find this connector, but honestly, I'm not going to bother. I can just cut this. I've got really way too much space, so I could cut this way back here and still do a return to stock if I wanted to. So just soldering these wires back together to here, it would put the switch right back on here if I wanted to. Back at the bench, we've made a little snip, and this is what we'll be using, and we'll be connecting that to our crimps, which I'm going to use this yellow type crimp connector, which is good for 10 to 12 AWG gauge wire, because these are about 14. These are 14 gauge wire, and I'm going to be putting 2 into here and crimping it down like that. And then these 6 leads are similar to the 6 connecting points on the existing switch. So we just have to match up the 2 wires that control the motor, and then the common ground and power, and then we should be good. All right, just to double check the polarity on this, the red striped wires, so as I said, these 2 control the motor. And so the red stripe wires are the ones that are, when that's positive, it'll go up. The window will go up. And how do I know that? I press the up button, which is this direction, and check the continuity between each of the leads with the positive, common positive, which is this solid red wire in the middle. And I got continuity on the red on this side, and the red on the outside. So the outside leads here of those middle ones are the ones that, when positive, make the window go up. So all we're going to do is match that same polarity over here, and we'll be all set. Now, it really doesn't matter too much because you can always just like flip it around if it's wrong. You just wire the common positive and ground in the middle, and then the other ones on the top or the bottom. It doesn't really matter because we're going to be jumpering them across. But you can turn them around. But just for sake of cleanliness of wiring, if we kind of know what they are and we don't have to fiddle with it, then we don't have to screw with the lengths of wire or get it kind of twisted or anything like that. It can just be a clean. All right, I've quickly stripped some leads that are going to be our little jumpers across to the various things. I used this kind of tool. It's about 20 bucks. Definitely worth it. You can strip all these things very quickly without any risk of nicking the wire. So definitely recommend picking this up. All right, we've got these mostly wired up now. We've got these crimped with the yellow connectors, and I'm going to crimp the other half of the jumpers to this blue, which is good for 14 gauge wire. And just to be sure the connection polarity on these switches, the bottom lead here, which is labeled number 3, is what happens when you push, is connected when you push up. So I'm pushing kind of up with my finger there. And so that's connected to the number 2 lead, which is right there, if you can see that, when you push up. So that's what I'm going to connect the red striped wires to, is the bottom, number 3, and then jumper over across to the top, number 4, and then the same thing over here. I'm going to connect the other side with the other side of the I think it's the green wire, striped wire, and cross connected like that. So we got these crimped, and it's not too bad. It looks a little wacky, but I mean, there's really no getting around that. It's fairly tight in there. I don't think I could have made these any smaller really and have it be workable. So we basically got like I said, the power is going to this input 2 that's in the middle, and the ground side is on the other side, and the up red part is going to the bottom, number 3, and on this side as well. And this is the driver's side, which I labeled with a D, and this is the passenger side, which I labeled with a P. So you just kind of have to flip it back and forth. They make it a little bit annoying because normally in the car, this is set up like this, so that it's kind of like this. So when you push forward, that's what makes it go up, and when you push back, that's what makes it go down. So you just kind of have to flip it back and forth a few times. So hopefully I got this right, and we'll take it out to the car and do a test. All right, back out at the car again, and to save you the trouble of a bunch of boring measuring and drilling, this is the finished product with the delete plate that's in here. I got a new delete plate that I just cut out of some metal, and then I kind of brush finished it. And basically what I did was I just measured where these need to go. They're kind of tight in there, and so I'm gonna wrap some electrical tape around those bare connectors. But that's how they plug in. And then on eBay I got some little these little aluminum U bolts, and they just have an inch separation, so I drilled those, put those in. So now I got the little clicky flap switches. So that's all mounted, so we'll get this back in the car and we'll try it out. Put back together, do one last test. Make sure you plug in your hazard and your headlight pop-ups. Otherwise you'll freak out the first time your headlights won't work. Make sure everything's working. And need to put more grease on this one. This one's super slow. And we're all set. We can screw it down. If you took out your eyeball vents, then you can screw down the screws in here and the two at the bottom, and you should be all set.